So far, we have been graphing lines, straight lines. Today we're going to be graphing quadratics. The shape that they make when we draw is called a parabola and can be seen naturally in the world around us. Unlike a line, now a quadratic has an exponent. And in terms of a quadratic, an exponent of 2. That is one way to differentiate between linear systems, a line, and quadratics. So this is a table of values for x and y. I've chosen the x values, we're going to sub them in. So what we're essentially doing is saying, what is y when x is negative 3 squared? And negative 3 squared, negative 3 times negative 3 is 9. Negative 2 squared is 4. And if I continue to fill that in, when I substitute in my head, negative 1 squared is 1, 0 squared is 0, 1 squared 1, 2 squared 4, 3 squared 9. If we take the first differences, the difference between all the y values, when we do it for x, we can see plus 1, plus 1, plus 1, plus 1, plus 1, plus 1. In fact, let's write it. If our first differences were the same, we'd expect this relation to be linear, or a line. So let's check. From 9 to 4, we go down 5. From 4 to 1, we go down 3. From 0 to 1, now we go up 1. 1 to 4, we go up 3. 4 to 5, we go up 9. Again, they are not similar. They're not the same, so it's not a line. From that point, we're not done. We need to take the second differences. We're going to do that again. If we do it again a second time, from negative 5 to negative 3, we go up 2. From negative 3 to negative 1, we go up 2. Negative 1 to 1, we go up 2. From 1 to 3, we go up 2. From 3 to 5, we go up 2. All of a sudden, we see that those are the same, and that's what we're looking for. As soon as those are the same, that means we have a quadratic, or a non-linear system. That shape that it makes is a parabola. So let's actually graph these points. Negative 3, 9 is just a point. So negative 3 up to 9, negative 2, 4, 1, negative 1, 1, 0, 0, 1, 1, 2, 4, 3, 9. This looks like a V, but we're going to call it a rounded V. So all those points match up here. We have negative 3, 9, negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4, 3, 9. This is our most basic parabola, our starting point. To draw these, we connect the dots in one fluid motion. It's a V that is curved or a U that continues to open up. Arrows on the end because it continues forever. If we were to follow this pattern, we probably say that, okay, the second difference is going to follow that same pattern, unit 1 patterning. 5 plus 2 is 7, so we expect the next one to be 9 plus 7, which is 16. If we follow this pattern, 4. And what's 4 squared? Yeah, that's right. 4 squared is 16, so it works out. So our next point would be 4, 16. And now we have graphed this. When we look at this actual shape, this relation, a quadratic, which is called a parabola, the actual shape it makes, or this shape, highest or lowest point, I don't like those words. We're going to use the words maximum or minimum. And so right now, if you look, we can say that it has a low point, a minimum, of 0, or y equals 0. It doesn't have a high point because it continues forever. So we can only state what we see. It's the bottom. It's the bottom of a hole. It's the bottom of a valley that goes up forever. The y-intercept, we're used to this. Where does it cross the y-axis? At 0. Are the second differences positive or negative? Well, let's see. They're all positive, and this opens up. There's no top to it. There's an actual bottom. There's no top, so it opens up. All right. So that's our most basic parabola. We're using our table of values. First differences, they're not the same. Second differences, they're the same. That tells us that is a nonlinear, which we now see as a parabola. We graph all the points, and there's our shape. And now we can take some information from viewing our shape. Let's try the second example. We're going to be looking at the equation y equals negative x squared plus 2x plus 3. So again, if I've chosen x as negative 2, I'm going to sub it in everywhere. So I'm not going to write all my work. I'm going to be doing it in my head, which I know I tell you doesn't show your work, but we'll do the first one. Negative 2 squared is 4. Minus 4. 2 times negative 2 is minus 4, so that's minus 8. Negative 4, take away 4 more. Negative 8 plus 3 is negative 5. When x is negative 1, negative 1 squared is 1, times a negative is negative 1. Take away 2 more is negative 2. Sorry, that's negative 2. Negative 1, take away 2 is negative 3. Plus 3, 0. Again, these are points. When x is 0, 0 squared is 0, times negative is 0, plus 2 times 0 is 0, plus 3 is 3. When it's 1, 1 squared is 1, times negative, negative 1, plus 2, plus 3 more is 4. When x is 2, 2 squared is 4, times negative is negative 4, plus 2 times 2, negative 4 plus 4 is 0, plus 3 is 3. We do the same thing. Let's just compare and see how it works. From 5 to 0, we go up 5. From 0 to 3, we go up 3. From 3 to 4, we go up 1. And from 4 to 3, we go down 1. Again, not the same. So this shape, this relation, is not a line. We don't stop there. We're going to do second differences. From 5 to 3, we go down 2. From 3 to 1, we go down 2. From 1 to negative 1, we go down 2. Again, those are the same. Sweet. We have a parabola. Let's graph those points. Negative 2, negative 5. 0, negative 1. Sorry, negative 1, 0. 0, 3. 1, 4. 2, 3. So we have the start of the curve. That one's not there. As I continue, I can see the pattern. I have this point which ends up being a mirror where the left is a mirror of the right. I could continue to try and get the other points. So let's see. This is sort of the mirror point, and this one is 2 away. This is called the axis of symmetry. If it's 2 away to the left, it's going to be 2 away to the right. Same here. This is 1 further to the left, down at negative 5. So let's go 1 further to the right, down at negative 5. We're going to draw our parabola. Nice fluid motion. Ideally not being completely a point and not going straight back in or straight, but continuing to open. Not that big a deal, but the more we practice, the better it gets. Sometimes you need to move the sheet around, but since I've taped it and ripped it, we're going to leave that. So we got our parabola. Again, if I look at this and follow that pattern, -2, -1, take away 2 more is -3. 3 take away 3 is 0. This pattern is going up by 1, so our point 30. Hey, there it is. If I did that again, I would probably get the point for -5. So now that we've graphed it, we can once again look at it. High or low, we don't like that. We want a max or a min value. Right now there's an actual top, so there's a maximum. Max of what height is that at? 4. The y-intercept, where it crosses the y-axis, 3. Second differences, positive or negative, look at that, they're negative. And it opens down. It continues to get further and further in the negative of the y aspect. So it opens down. So a relationship in the shape of a parabola, that shape, is called a quadratic. And we can call it an equation or a relation, kind of interchangeably there. Now the way it's represented is the general form. Just like a line, remember that a line, y equals mx plus b, m and b have certain special connotations. The standard form of a parabola, y equals ax squared plus bx plus c, as we saw in example 2. So this form is called standard form for a quadratic or a parabola. And the special things to note here is that a, b, and c are all numbers. If there is no b, 0x, we still have a parabola. That just starts to tell us something about it that we learn later on. If c is 0, it starts to tell us something later on. It's still a parabola. If a is 0, there's no x squared term, and we basically have a line. We need that x squared term for it to be a quadratic or a relation. That is another way that we can tell that it's a parabola. The exponent on x is 1, it's a line. The exponent on x is 2, it's a quadratic.